In the area of science and gigantic mysteries, the subject of what existed previously to the gigantic explosion has blended conversations and intrigued characters for quite a while. This huge question doesn't just test how we could decipher the universe, it challenges the genuine furthest reaches of human knowledge. Imagine standing at the edge of existence, looking into the colossal shadowiness and pondering what lay there before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. However, was there a second earlier than this? Could there have been a condition of nothingness, a calm before the cosmic gathering started? And if this is true, what was it? Or perhaps there was something much more alarming that existed before time itself. As we jump further into this question, science takes us on a journey past the universe's beginning point into thoughts that challenge our consciousness. Physicist Brian Cox, known for his investigation into the wonders of the universe, suggests that something surprising might have existed before the enormous detonation. He moves us to reconsider our thought of reality and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider secrets that might make sense of what existed before all that. We'll explore thoughts like self-important development, quantum changes, dark energy, and even multiverses. The answers we've revealed might just paralyze you, yet they could also open new understandings of our position in the universe. Get ready to jump deep into a world beyond imagination and science, where the obscure still winds around the shadows, leaving scientists floored and sometimes even upset. We ought to explore what existed before the Big Bang and why these theories challenge all that we thought we knew. To appreciate what may have existed before the Big Bang, we first need to painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely hot and dense, growing rapidly to set off the development of all matter, energy, and boundless forces. When we look toward the night sky, we see proof of this hot beginning, with galaxies spreading out this way and that from an early stage. However, for what reason did this happen? Furthermore, was there a period before this thick, hot start? As indicated by the theory of enormous expansion, there was without a doubt a previously, and it was not even close to void or peaceful. Vast expansion suggests that before the Big Bang, the universe was in a state that was cold, vacant, and loose, essentially like an immense vacuum. Anyway, this vacuum wasn't entirely unfilled. It contained a gigantic amount of energy that fueled the quick extension of space itself. This extension, called inflation, happened so rapidly that it basically established the groundwork for all that would continue in a part of a subsequent space, extended at unfathomable rates until the extension slowed down, and the energy changed into matter particles and the forces we see as the Big Bang. But what was the nature of this energy? For what reason did it suddenly grow the universe? And why did it stop? Specialists believe that this inestimable expansion made patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly with minuscule air pockets forming here and there, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Our own is just one of many. This huge, mind-bending reality challenges our understanding of the very universe itself and leaves us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not real at any rate. As per our current understanding, regardless of whether you eliminated all energy, particles, and radiation from the universe, it would still not be genuinely void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable embroidered artwork of something, even in its most vacant structure. Regardless of whether we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality alone is bewildering to specialists, as it suggests that true nothingness might be impossible within our infinite comprehension. Space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy except quantum fields and major constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a peculiarity called zero-point energy. which represents the least possible energy condition of quantum fields. In this state, particles can still momentarily appear and evaporate, making a spooky resonance of movement even in what should be empty space. This challenges our idea of a real void and suggests that, yes, even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash lighting another universe, while inflation continues in different areas, making countless other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept of a fractal universe, where each new universe might actually make its own Big Bang. Every universe exists as a separate independent domain, unaffected by the others because of the rapid expansion of space. For researchers, this hypothesis is both exciting and upsetting, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe being just one bit in a giant cosmic structure, forever expanding and constantly making new universes. And what if the disturbing reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? How we may interpret nothingness changes when we consider quantum field theory. According to this theory, the universe is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields momentarily, acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. This constant movement in what should be nothing suggests that the universe doesn't recognize our concept of emptiness. The fields and forces endure, filling the universe with a hidden energy that prevents absolute nothingness. This understanding raises an intriguing question. If fields make particles, and particles make matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? From certain perspectives, the fact that dark energy exists today is a leftover of an energy field from before our universe's development. The properties of dark energy seem to suggest a colossal hidden force that might have existed in some form prior to the Big Bang. Some theories suggest that dark energy, in a much stronger state, could have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that regardless of whether our universe were exhausted of all matter and radiation, this force would continue to expand the fabric of space-time. This thought leads to an upsetting question. If dark energy was present before the Big Bang, could it have formed the circumstances that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, that the universe goes through endless cycles of birth, death, and resurrection. In this model, the Big Bang is not a one-time event but rather part of a timeless rhythm, where universes expand, collapse, and then regenerate in another cycle. This theory suggests that our universe might have been reborn from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but rather an eternal series of universes emerging, growing, and renewing themselves over and over again. Cyclic cosmology raises significant questions about time, as it suggests that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was just another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this theory offers a rich answer to the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our ideas of time and existence. Early-stage gravitational waves are another intriguing idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as the echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of gravitational waves from the pre-Big Bang era could be the key that unlocks a new understanding of our cosmos. The search for what existed before the Big Bang continues to unfold with new ideas that reshape our understanding of the universe. These explorations lead to even greater mysteries about the nature of time, energy, and existence itself, building on the theories surrounding the nature of the universe before the Big Bang. One fascinating hypothesis involves the concept of the quantum foam. At the most microscopic level, space is not empty but instead consists of a highly dynamic, fluctuating quantum field. This quantum foam, as it's called, suggests that even in the absence of matter and energy, there are still quantum fluctuations, tiny, momentary changes in energy that can create and annihilate particles. This foam of activity could have been the precursor to the universe, possibly giving birth to the first particles and forces that later became the fabric of our observable universe. The idea that the universe might have emerged from quantum foam is rooted in the principles of quantum mechanics, where uncertainty and probability are fundamental. According to Heisenberg's uncertainty principle, there are limits to how precisely we can measure the properties of particles, such as their position and momentum. This leads to the possibility that even in a seemingly empty space, particles can spontaneously appear and disappear. If such quantum fluctuations were significant enough, they might have given rise to the enormous energies that eventually led to the Big Bang. This theory proposes that the Big Bang wasn't the beginning in a classical sense, but rather the result of a large-scale fluctuation in the quantum foam that reached a critical threshold, sparking the rapid expansion of the universe. In addition to quantum foam, some cosmologists suggest that the universe could have originated from a state of false vacuum energy. The false vacuum theory posits that the universe, prior to the Big Bang, existed in a false vacuum state, a form of energy that is not in its lowest possible energy configuration. This state is unstable, and as it decays, it can lead to the formation of a true vacuum, which would release an enormous amount of energy and trigger inflation. The false vacuum concept ties into the notion that the early universe might have been born from a metastable state of energy, and that its sudden collapse led to the rapid expansion that we associate with the Big Bang. Some theories extend this to propose that our universe could have been born from a vacuum decay process, where the energy from this collapse sparked the rapid inflation and the creation of spacetime. Another concept that has emerged is the holographic principle, which suggests that our universe, along with everything in it, might be a projection of information encoded on a distant two-dimensional surface. This theory, which is related to black hole thermodynamics and string theory, implies that the universe might not be as real as we think. Instead, the three-dimensional world we experience could be a manifestation of information stored on a boundary, and time itself could be an emergent property. From this viewpoint, what came before the Big Bang may not be a traditional before at all, because our perception of time and space could itself be a constructed illusion. The holographic principle suggests that the true nature of reality could be more abstract and multidimensional than we can comprehend, leaving us to reconsider not only what existed before the Big Bang but whether there even is a before in the conventional sense. The idea of a cyclic or eternal universe also ties into advanced models of time and space, where the Big Bang could be part of an endless process of creation and destruction. This is known as the Big Bounce theory. In this scenario, instead of a single, one-time Big Bang, the universe undergoes periodic contractions and expansions. After each contraction, a new Big Bang occurs, creating a new universe that is similar to but distinct from the previous one. If this theory is true, it could imply that the universe has always existed in some form and that the Big Bang is just a moment in an eternal cycle. This would challenge our traditional understanding of the beginning of time and existence, as it suggests that time itself is cyclical and infinite, rather than linear and finite. There is also the concept of the no-boundary proposal, introduced by physicist Stephen Hawking, which posits that the universe does not have any boundaries or edge, either in space or time. According to this idea, the universe may have been self-contained from the very start, with time itself beginning at the Big Bang and evolving out of quantum fluctuations. In this model, the notion of a before the Big Bang might be meaningless because time itself emerged with the universe. Without a boundary, the question of what happened before the Big Bang would be akin to asking what is north of the North Pole. In this sense, the Big Bang would not mark the beginning of time in any conventional sense, but rather an unfolding of a timeless and boundless quantum state. The exploration of what existed before the Big Bang is one of the greatest intellectual challenges of our time. As scientists continue to probe the deepest mysteries of the universe, these questions push the boundaries of what we understand about the laws of physics, the nature of time, and the origins of existence itself. Whether through theories like quantum foam, false vacuum, the holographic principle, or cyclic cosmology, our search for answers continues to unravel the mysteries of the cosmos. What might have come before the Big Bang may ultimately be far beyond our current comprehension, but each discovery brings us closer to understanding the true nature of our universe, and perhaps its ultimate fate.